a different type of question. Let's say we have a function f that is continuous and differentiable, and such that f of 2 equals 1 and f prime of x bigger or equal than 2 for x between 2 and 5, the endpoints included. How small can f of 5 possibly be? And if you think this question is a little dry, before we start, let's give an interpretation of a situation where this could be important. Okay, let's say that f of t is a company value at year t. Okay, so a company is in the stock market and f of t is given by the company value, the total value of the company at a given year. And we know that f of 2 is 1, let's say it's a modest company, so 1 million at year 2, or we could say 1 billion, whatever, doesn't matter. And then f of 5, this is going to be the millions at year 5, okay? And then when we think about f prime of t, this is the rate of change of the company value. Okay, so what we are asking in this question is a worst case scenario. Okay, it's a conservative estimate. A conservative estimate of the company value at t equal 5 when we know that f prime of t is at least 2. Okay, the rate of change is at least 2. So the analysts may have reached the conclusion that in this period, to the years 2 to 5, the company is expected to have a potential for growth or rate of change that of at least 2. Okay, that would be millions per year, I guess. Okay, so we can have this type of interpretation in mind. It doesn't really matter for the problem, but now let's go for it with some idea in mind. Now, this problem, you are not given a particular function, so in principle, you can't answer the question, how small can f of 5 possibly be? I don't know, I don't have any f here. But you're given a few hints. First, you're told that the function is continuous and differentiable. We are given a closed interval, okay, and it's talking about derivatives. Okay, so all these ingredients together, they are kind of talking about the mean value theorem. Okay, you see, a function that is continuous and differentiable on a closed interval, and we have a derivative involved. So that may help. Let's see if that approach takes us somewhere. So mean value will happen there. Mean value theorem. Okay, so what does the mean value theorem? Remember here, I will say it again, f continuous, differentiable on a closed interval to 5, okay? That we always need to check. This is the reason why I thought about the mean value theorem, actually. So the mean value theorem says that there exists C in the interval to 5 such that f prime of c is f of 5 minus f of 2 divided by 5 minus 2. And we may think that the situation has not improved, but it has improved. Actually, we are half the way through. Why? Let me copy paste. Now we need to see what we have and what we need, okay? So here, f of 5 is what we are asked. So that one we don't know. But f of 2 we have, is equal to 1. And then 5 minus 2 is 3. So that's no big deal. But then, and you could say, well, f of prime of c, I have no idea. But if we notice, we are told that f prime of x is bigger or equal than 2, at least 2, for every x in the interval 2 to 5. All right, so that means that no matter how bad things go, this is at least 2. This is given by the problem. So that's it. We can solve for f of 5. So f of 5 minus 1 bigger or equal than 2 times 3. Okay, that is 6. So f of 5 is bigger or equal than 1 plus 6, that is 7. So we conclude that the company value, the expected company value after 5 years is going to be at least 7 millions. And this may help us to decide if we want to invest or not. Okay, it may be too risky or it may be a very good deal, even in this worst case scenario.